All right, so I'm going to quickly go through the Kahoot that you guys did on week 6. Feel free to just go ahead and scroll to any question that you were confused by and play along with me if you'd like. All right, so we want probability notation that a student does not have long hair. So nothing here about the student's gender, right? Male or female or sex, but there is only this idea of long hair and we have a not. So we should be using blue for the not complement. We don't want to just assume the opposite of long is short because we don't know that these are binary, right? That there's this one or the other. There could be medium length or something else. So we do want to use that complement notation. Next, male or short hair. Simple enough. We have our sweet keyword of or. Boom. All right. Male, long hair. So we need both M and L, but you'll note there's no and between. We actually have that keyword of given. Long is after given, so we know they have long hair and want to find the probability of them being male. So we're looking at the yellow one. I'm going to keep trying to click over here. All right, so that given is our keyword. Probability of short hair of all the female students. So we have female, we have short hair, we need F and S, but all of our answer choices have that. There is no and or. We do have that keyword of telling us that our whole is female students, not all students. So F is what's going to go behind the line, and we're looking for probability of short hair. So probability of short, given, or of the female. All right, these were the straightforward ones. I'm sure we did okay on these. All right, this one's a little bit more challenging. Randomly selected male with short hair. There's no and or, but there's also no of, if, or given. But we do have to think a little bit harder here. But it does say the probability that a randomly selected student. So this is telling us that we're looking at every student as our whole. This is not a conditional. And with is just a kind of not so clear cut way to say and. So this one is actually M and S. All right. This next question was all about making sure we understood the contingency tables add up and down columns and rows. So if we have 16 females who prefer to hike near lakes and streams and a total of 41 people who prefer to hike by lakes and streams, that means our number of males must make this true. 16 plus that equals 41. So it has to be 25 males. So this is true whether we're doing this with actual tallies or with probabilities themselves. All right, 7 more. Now is when it gets interesting, right? So pulling a marble out of an urn. Now, again, the most important thing here is the phenomena. We're only pulling one marble. So A is that it's red, B is that it's blue. The easiest thing first is to tackle joint or disjoint. Is it possible if I'm pulling one marble for the marble to be both red and blue? No. So we know that we're in disjoint land. Now, we could immediately know, because I talked about this in my lecture, that it's not possible to be independent and disjoint, so we have to be here. But we'll also talk about why. I was running out of time, so I had to buzz in. If I know that the ball is red, that does give me an increased probability the ball is blue, right? It immediately takes that probability to 0. So if the ball is red, the probability is blue is 0. Again, I saw mistakes on this again and again on the discussion board 6. Students started talking about the next ball. Oh, why is this about balls and marbles? Whatever. But we are only grabbing one marble. So that first marble, if we know it is red, what do we know about that same marble? Because we're only pulling one. All right. Randomly sampling a person. That's our phenomenon. Our events are A, wearing a raincoat, and B, carrying an umbrella. Is it possible for someone to wear a raincoat and carry an umbrella? Yes. So we have joint events. We're down here. Do these two things depend on one another? My argument is yes. If it's raining, people are more likely to have a raincoat or an umbrella, and maybe even both, right? But there is that sort of lurking variable of the weather that would influence, both of these things. Now, if you wrote me a good enough argument for why these two things would be independent, I might give you full credit on the exam for this. But even if your argument is that people would wear one or the other, then you're telling me again that there's a dependence, because you're saying if somebody's wearing a raincoat, the chance of them having an umbrella is zero, which does have an influence. So be very careful with your justification here. You want to say that they're equally likely to be carrying an umbrella whether or not they have a raincoat on, as opposed to saying somebody with a raincoat won't have an umbrella or somebody with a raincoat will have an umbrella. Those are both giving us a dependency in different directions. Cat, I'm going to kill you. Stop doing that. My cat is trying to go outside even though it's raining because she is a dumbass. All right. Hi, baby. All right, let's keep going. Flipping a coin. So again, we're flipping one coin, except for it says A is the first flip is heads and B is the second flip is heads. Is it possible to flip a coin and have the first flip come up heads and the second flip come up heads? Yes. So we're joint. Does the outcome of one flip influence the next? No. So we are independent. Cool. And now we get to the other way I like to test independent or disjoint, the actual values, which I showed you how to write a maybe quick table for yourself. So A and B, independent. That means we just get to multiply our different probabilities together. So 0.3 times 0.5 gives us 0.15. Easy enough. As soon as I see the word independent, I always write down that formula. A and B is A times B. And I never use it unless I have that sweet word independent in my question. Now they've told us that they're disjoint and asked us for the and. So disjoint means that there is no and, right? There is no overlap. They can't occur at the same time. So now our and has got to be 0. We have the two separate circles. And remember what I talked about in the knowledge check review, our and is always going to be smaller than the smallest one of these because we're taking our two circles and we're taking off that intersection. So there's no chance of having, the yellow or the green. Cat. Oh my God, you suck. Sorry. 2 more. So we still have the same A and B, except for now we're looking at independent and we want or. So or is going to be the two things added together. The baby's farting. Subtracting off the intersection. So this plus this minus the and we found in that first question will give us the yellow. So 0.8 minus that and, is 0.635. And then the last possibility, if you hadn't caught on to this trend when you were doing this in class, now we're doing disjoint and looking for or. So add them together, boom, boom, subtract off the and, which was 0, gives us the green one. So like I said, the independent and disjoint, I know we have a struggle to kind of get them down at the beginning, but there's been so much practice on them that I'm hoping that those 2 questions that might be on the exam will be pretty straightforward when they appear. I guess I can show myself on the podium. I did perfect.